Hi everyone, this is Dr. Vaughn. I'm going to do a video about our assignment for this week. This is week 6. And there have been a few questions that I received, and some of the questions I have been able to reconcile the answer, and a couple of them in particular, questions 9 and 10 from your homework, I get a different answer than even what the book is publishing. And so I'm going to talk through at least what my response is, which I know is consistent with at least what a couple of other students have gotten on this question as well. And I'll talk to you about what to do about those. So first, let's take a look. We're going to work our way backwards. This is question 10, and the question is to develop an effect size measure rounded to 2 decimal places where you have an ANOVA table. The mean square error is 10. You have random samples of size 6, which were from each of these 4 different groups or populations. And then they also tell you that the sum of squares total was 250. So what I did with those numbers is I created a little ANOVA table, which is right here. And so up here you have your 4 different groups. Those are the treatments. And I put in here the degrees of freedom, which is the groups minus 1. So since there were 4 groups, you can put in degrees of freedom as 3. You also know that there's 4 groups with 6 patients each in it, or 6 observations. That gives you a total sample of 24. So the total degrees of freedom is 24 minus 1, which is 23. And then 3 plus 20 has to add up to 23. So I knew that this number had to be 20. So you can start by filling out this degrees of freedom. And then the other thing that they tell you is the total. They give you this number, so I plugged that number in. I knew all of these numbers because I knew the groups and the total samples. And then the other number they give me is this one right here. So I put in those numbers, and then I calculated this one over here because this number divided by 20 has to equal 10. So I knew this number had to be 200. And then I could figure out this number, which I knew had to be 50, because these two things have to add. 50 plus 200 has to add up to be 250. You don't really need to, but I computed the mean squares for the treatments, and then I calculated the quotient to these two things to get that F statistics, which we measure against the critical value to determine in a null hypothesis whether we'd be rejecting the null or not. But the effect size for ANOVA is called eta squared, and so I'm computing this eta squared, which is the sum of the squares for those treatments divided by the total sum of squares. So I really just needed this number up here, which is the 50, and then I'm going to divide by the 250, and if you round, that's, well, not even round, that's exactly equal to 0.2, which is 1/5. So I come up with an answer of 0.2. If you look over here, it says that the answer is 0.25, and I'm not really sure where that comes from. So you can either, on this question 10, you can either put in 0.25 and get the question right, even though you're typing in the wrong answer, or you can type the answer 0.20 in to get the right answer, and then it's going to mark it incorrect. Either way, on the homework, if you haven't seen this by now, you actually get credit for doing all of them, whether they're all right or not. So by completing the homework, you're going to get your 2 out of 2 points for this week. But I wanted to make sure that we had this conversation so that if you have some similar quiz questions that you need to tackle, then you won't be misled and you have an idea of how to do this. All right, so now we're going to go backwards and we're going to look at the same thing for this question 9. So over here, it tells you that the effect size, here we have a 2-sample t-test, and they want the effect measurement for this 2-sample t-test. Well, the effect measurement is this Cohen's d value, which is basically the difference between the sample means divided by the pooled standard deviation. And it's not going to be anywhere close to this number of 9.51. So once again, the answer that I come up with is 0.44. I'll quickly kind of run through how I come up with that 0.44. But again, I think that this answer is coded incorrectly in the system. And I would suggest that you, if you have this link available on your system, report a content issue. I've reported it as well. It doesn't look like they've fixed it yet. And, but I think I've done everything that I can to try and alleviate this situation. We really should maybe talk to Ashford and see if they can kind of force McGraw-Hill to make some correction or at least change these questions out, because I don't believe they should be giving you in a class this challenging anyway questions that are just coded incorrectly and misleading. But anyway, I'll get off my soapbox for a minute and I'll show you how I come up with the 0.44 on this one. So I'm going to take this 24.51, which is the first sample mean, and I'm going to subtract the second sample mean, which is the 22.69. And I'm going to divide by the pooled standard deviation. Now the pooled standard deviation is a square root of, and I got to take n1 minus 1 So I'm going to take 35 minus 1 is 34. And then I need to take the variance of that first group, which is the square of the standard deviation. So I'm going to take 4.48 and square it to get the variance. And then I'm going to take the n minus 1, so that's 40 minus 1 is 39, and then times the variance here, which is 3.86 squared. And then on the bottom, I'm going to add the two n's together. So I have 40 plus 35 is 75. So if you just do this with your calculator, I come up with a 0.44. It's like 44099. So either way, it should round to 0.44. And that's the answer that I think you should have for an effect. But in particular, the actual difference between these means is only, about 2? And then you're quotienting that by the standard deviations. And even when you pool them, it should be somewhere in the neighborhood of what those sample standard deviations already are, which in particular is in that 4 neighborhood. So if you take this number, which is around 2, and you divide by something that's around 4, the square root of it is the pooled standard deviation is around 4. You're going to get something that's around 0.4, 0.5, something like that. So I don't have any idea how they're coming up with an effect size that's so large in this case. It should become smaller than the difference between the means, not bigger. And finally, I want to talk about question 8. This one I do come up with the same answer as they do, and I'll show you what I do for question 8. So let me just clear off the whiteboard really quick here. And the important thing is here, they give you a whole bunch of information that's not really even relevant. So they tell you about the sample size and the alpha value and everything else. But you really have this hypothesized population. What Weight Watchers tells you is that you should be losing 10 pounds. And then you have this sample mean, which was on average, they lost 9 pounds. All right, so the sample, they lost 9 pounds, and the population, they lost 10 pounds. So when you're computing effect, you're taking the difference between these means, so that 10 minus 9, and then you're dividing by the standard deviation. Now, the standard deviation in this case was given to us. It was given to us as the number 2.8. And so we're not actually calculating the standard error. And that's important, right? Because in the standard error, you take the standard deviation and divide by the square root of n, which in this case would be the square root of 50. And so your standard error was going to be much, much, much smaller than 2.8. But the standard deviation is 2.8. And the Cohen's d is really just the difference between the means divided by this standard deviation. It's like doing a z-score computation. It's like how different are the means from each other, and then normalizing that in terms of counting it by standard deviation units. And so if you calculate these and then round to 2 decimal places, I do get the value that they say is the correct answer here, which is 0.36. All right, so this is Dr. Vaughn. Happy Sunday. Hope you all had a blessed Thanksgiving, and I'm looking forward to reviewing your final papers. Please let me know if you have any additional questions, either from the homework assignment or from the quiz. You only get the one attempt at the quiz, so I can't really help you real time on that. I haven't heard a lot of complaints about incorrect things, just things that maybe students weren't prepared for, but I have seen some complaints about the homework exercises in the past. Now, maybe I'm wrong. Maybe there are some quiz questions which are coded incorrectly, in which case I'll do what I can to try and fix those if you bring them to my attention. All right, I hope you all have a blessed Sunday, and like I said, I look forward to reviewing your papers. I'm going to sign off now. Have a good day.